Yeah, what I'm going to today is in the week 3 is basically the relational database design. So yeah, this is what we talked last time, right? So there are some steps of database design. At first, we are going to do conceptual data modeling. So it's basically very similar to making a building. So at first, we conceptually think what we want to make. So that was conceptual data modeling. So there's business scenario and the business rules. And from there, we think about what kind of data we want to store. So we define the entity and how they are related. So we define the relationship, and we also think about the cardinality. What's the association of the relationship? So we think about those things. So by doing that, we do the conceptual data modeling. So that's what we talked about last time, and that was the basically assignment 1. And once you finish conceptual data modeling, you have something like this, which is a ER diagram. That's what we call. And the next step is relational data modeling. So based on our conceptual data modeling, so basically in the architecture, based on the concept, we define exactly how long it should be and what should be the size of this room and something like that. So we define more details before we actually implement it. So in the database design, it's exactly the same. So we do relational data modeling based on ER diagram. So we implement the ER diagram, and what we do in the relational data modeling is just simply translate ER diagram into relational model. So we call this as a relational model or relational diagram. And basically relational model, here we define what will be the foreign key. So how the relationship will become uh, embedded into a table, something like that. We are going to basically talk about how to do relational modeling today. So it's our main topic of today. And once you finish relational data modeling, implementation is very straightforward actually. So it's exactly the same. So when you have a blueprint, you know how to build it, right? So you just follow everything there. It's same here in the database design. So once you have a relational model, simply you follow it and then you implement it. So usually, as long as you have a good relational model, you put it inside the database software, and the software will implement it for you. So usually that's what's happening these days. So you don't need to worry too much about the actual implementation. As long as you have a good model, good diagram, then implementation is very straightforward. So the next one is this. Yeah, so basically this is what we talked about last time, right? So we had this example. So in the business event of a professor teaching a course in a university, we define the professor as an entity, course as an entity, and then for teacher relationship, we made it here as a one-to-many relationship. So we can have this simple ER diagram. And let's say that we have a ER diagram like this. Then, then I will show you how to translate this into a relational model today. The first thing is this. Based on the ER diagram, you find an entity. There are two entities here, professor and course. And all the entities in the ER diagram becomes a table in the relational model. So basically, what we are saying here is this. Every entity will become a table when you implement database system. So professor entity becomes a professor table, course entity becomes a course table. So we make this box shape here again, and we make this line, and we put the name of the entity here on the top. And on the left side, we identify whether it's a primary key or foreign key. And on the right side here, you put the attributes basically. So that's how you translate entity into table in the relational model. So currently there are one primary key and 1, 2, 3, 4 attributes. So we put one primary key here and we specify that is primary key and we list 4 attributes. Exactly same for the course entity. So for the course entity, we put the course name here and we put all the attributes and we specify course ID is primary key. So that's the first step of relational modeling. So changing all entity into a table. And the next step is representing relationship in the relational model. So we can do this. So if you remember, in the first week, we talked briefly about the foreign key. And basically, in the database system, we are using a foreign key to represent a relationship. So here, this is what we are doing. So whenever there is a relationship, we have to think about how it will be implemented. And I'll talk about the one-to-many relationship first. So depending on the relationship type, the way to represent that ER diagram into relational model is slightly different. So let's talk about the one-to-many relationship first. So in this case, we have one-to-many relationship because here maximum cardinality was 1, and here maximum cardinality is many. So we call it one-to-many relationship. So if you have a one-to-many relationship, basically you use primary key of one side table. Basically one side table is this one with the maximum one cardinality next to the entity. So in this case, the professor entity is one side table. And primary key of professor entity is step ID. So we use that as a foreign key of a many-sided table. So many-sided table is the course. So inside the course table, we put step ID, which is a primary key of one-sided table, and we use that as a foreign key. So that's a basic rule, basically. So to represent which professor teach which course, we can use a foreign key, and that foreign key is basically primary key of one-sided table. And then we make a link between professor and the course entity, and we simply use the same cardinality here. So once you have this relational model, then we are able to know how it will be implemented in the database system. Basically, we will have a professor table, course table, and we have some primary key on each table, and we will have a foreign key inside the course table, which will be linked to professor table, basically. So let me show you how this relational model will be actually look like when you implement it in the database system. So let me briefly show how this relational model is connected to the implementation. So once we have a diagram like this, like table, we know exactly how the records and data will be stored in the database. So we have a professor table like this, then basically in the database system, it will be implemented like this. So each attribute will be on each column, and when you record the data inside this table, you will put each data in each row like this. And as you see here, step ID is primary key, so this will be used as primary key. So yeah, so the direct question is here. So the foreign key will always be from the one-to-one relationship entity. And yes, that's correct. So whenever you have a one-to-many relationship, so depending on the relationship type, it's slightly different. But given that there is a one-to-many relationship, foreign key should be always from one-side table. So one-side table's primary key should always be foreign key of many-side table. Yeah, that's a rule when you translate ER diagram into relational model. Okay, and yeah, this is now course table. So how the course table will be implemented in the database system? It's like this, exactly same. So each column is each attribute, and now we have a course ID here, which is a primary key, and here we have step ID, which is a foreign key. And how this works, it's like this. So basically, we said that this foreign key will be used to make a relationship. So what does that mean is this. So we have a professor table here like this, based on our relational model. And we have a course table here like this, based on our relational model. Then you can see that this last field of the course table is a foreign key, which is primary key of professor table. That means this. So for this course, DSM is 6751. We want to know who's teaching this course. Then in the course table, you find this record, and you can see the staff ID who's teaching this course. It's 1111, right? So the professor who's teaching this course has a staff ID 1111, and this is a foreign key. So we can simply search this step ID inside the professor table, because in the professor table, step ID is used as primary key. So there's only one unique information that match with this step ID, which is here. So we know who is teaching this course. So that's how the relationship is created basically in the database system. You use the information of the foreign key and you search it in the related table. Then we are able to find the detailed information about that. So same for DSM 2051, we have this step ID number. So if we search this here, we can find that person's information. So that's how the one-to-many relationship will be implemented in the database system. Yeah, like this. So that's the one-to-many relationship. Let's look at different relationship. Now let's look at the one-to-one relationship. Then how we should be able to change this diagram into the relational model. So if you have a one-to-one relationship, the rule is this. We'll use a foreign key again. However, you can use primary key of any table as a foreign key of the other table. So in the one-to-many relationship, you have to use one-side table's primary key as a foreign key of many-side table. And when you have one-to-one relationship, because both sides is connected by maximum one cardinality, you can use any table. You can use primary key of any table as a foreign key of the other table. So in this case, if we have this diagram example with the person entity and passport entity connected by one-to-one binary relationship, then you can simply use person entity's primary key, which is Hong Kong ID, as a foreign key inside the passport entity. This design works. Or you can do the other way. You can use passport entity's primary key, which is the passport number, and you can put them as a foreign key inside the person entity. This design also works. So either way is fine. So you can simply use one side's primary key into another entity as a foreign key. So let me show you how does this work in the database. So when you make relational diagram like this, then basically we'll have a person table implemented like this, and we'll have a passport table implemented like this. So for every passport, we'll have a Hong Kong ID number, so we can search that inside person table. Then we'll know who has that passport like this. So basically adding foreign key inside the passport table will works. And the other design is also same. So if you put the passport number inside the person entity, that will also works in the same way. So that's one-to-one relationship. The last one here is a many-to-many relationship. So in the many-to-many relationship, if you use the similar way that I showed you earlier, so if you try to simply use foreign key here in the many-to-many relationship, actually it will not work. So let me show you why it doesn't work. So let's say that, so we covered this example last time, this diagram last time. So this is about professor applying for parking permit, and parking permit. So basically professor can apply many parking permit, and each permit should each permit can belong to many professors. So it's a many-to-many relationship between professor entity and the permit entity. When you have this diagram, if you simply use the foreign key as we did earlier, then you may have this kind of relational model. So we have a professor table, permit table, and you may think that you can simply use step ID here as a foreign key. And then you link them together using many-to-many relationship. So this design actually will not work. It doesn't work. Let me show you why. So in this case, we have a professor entity like this, and we have the permit entity like this. So for permit number 101, we have some attributes. And here on the step ID column, which is a foreign key, right? We have to store the information about who holds this permit, who has this permit. Since it is linked with many professors, so each permit can be shared by many people, you are trying to put many information here, right? So permit number 101 is shared by step ID 1111 and step ID 3333. So that's actually problem. So this doesn't work in the database system. So in the database system, when you have a table, each cell should have only one information. You are able to store only one data in each cell. However, in this case, you are trying to save two information, right? Because two people holds this permit. So basically, this doesn't work because it violates the rule in the database system. So this design will not work. Then what about this? What if you put permit number as a foreign key inside the professor entity? So this design will be like this. It's a similar problem, right? So step ID 1111, he may have a multiple permit. Then you are trying to put multiple information inside one cell. This is again violating the rule of the database system. So this design also doesn't work. So you cannot simply use primary key of one table as a foreign key of the other table when you have a many-to-many relationship. So yeah, one person is saying that can foreign key be primary key as well, but there's a problem, right? Because when we define this entity, we used, so for example, for the professor entity, we used the step ID as a primary key. So what you are saying is that whether we can use this and this together as primary key, right? This is primary key, this is primary key. So basically you are adding permit number here as primary key and use them together as primary key. Then we have a data redundancy problem. So what it means is that, so for this one, step ID, so we'll add a record, right? Step ID, 1111 key is in DSME, and he has a permit 101. And then 1111 again key, DSME, he has a permit number 103. So we have a data redundancy problem, right? So it's the professor table, and we want to use a step ID as primary key so that there is only one unique step ID, and we want to save all the professor information. But because we are making these two as primary key, now we have to save the same information multiple times whenever this professor is having a new permit. So if this professor has another permit, then you are going to save the same information again here. So this is a data redundancy problem. And the reason why we are using database system is to reduce data redundancy problem. But we are having that issue again. So this design doesn't work basically. Yeah, it is another good design. So there's a problem. So when you have a many-to-many relationship, basically simply using primary key of one table into use one table to primary key as a foreign key into another table doesn't work basically. So what we do is this. When we have a many-to-many relationship, we need to get some help of assignment table. So whenever you have a many-to-many relationship, we change that into assignment table. So this assignment table will simply keep all the information about the assignment between two tables. So the reason we are using this is because the relational database does not support many-to-many relationship, because basically you are not able to save multiple information in one cell. That's why. So we have to use this assignment table so that we have two one-to-many relationships to represent many-to-many relationship. So let's say that. So this is a rule how to change the ER diagram into relational model. So when you have a two entity like this, so there's a primary key of entity 1 is ID1, primary key of entity 2 is ID2. They are connected by many-to-many relationship. Then what you need to do is that simply this. So between entity 1 and entity 2, you make new junction table. You can call it junction table, assignment table, or whatever name you want. I just wrote down junction table, or sometimes I call it assignment table. And in this table in the middle, you use primary key of each side's entity as primary key here. So entity 1's primary key is ID1, so you put it here. Entity 2's primary key is ID2, so you put it here. And use both of them as primary key. And then you make a connection. And then you link it with the entity 1, and you link it with the entity 2, like this. And then for the cardinality, you simply bring this one here. So from entity 1's perspective, entity 2 was connected by one and many. So you put it here. From the entity 1's perspective, junction table will be connected by one and many. Same thing. Entity 2's perspective, entity 1 was connected by 0 and many. You put it here. So entity 2's perspective, junction table is connected by 0 and many cardinality. And then for the rest of cardinality here and here, you simply put 1 and 1. So that's the basic rule here, how you can translate many-to-many relationship into relational model using junction or assignment table. So if I show you one example here, earlier we had this professor applying permit business event. For this ER diagram, if we translate this into relational model, then basically professor table becomes table, permit table becomes table, and apply many-to-many relationship becomes an assignment table, and we are going to use primary key of a professor entity and primary key of a permit entity, put it here, and use both of them as primary key of this assignment table. And then we make a relationship. Then for the cardinality, from the professor perspective, it was 0 many, so we put it here. And from the permit perspective, it was 0 many, so we put it here. And for the rest of cardinality, we simply put 1 and 1 like this. So that's how you can transform many-to-many relationship in the ER diagram into relational table using assignment table. So let me show you how this actually works when we implement it. So I also want to show, in addition to showing relational model, I want to explain how this will be implemented in the database system and how this will actually work. So same example here from the earlier slide. So when we implement this in the database system, it will look like this. So we have a professor table, permit table. So simply professor table stores professor information only, right? And the permit table stores permit information only. And the relationship will be implemented based on the assignment table. So assignment table will look like this with the step ID and the permit number both as primary key. And it will keep all the assignment information only. So step ID 111 has a permit 101 and step ID 111 has a permit 103 like this. And another step has another permit, another step has another permit like this. So basically this table, we are listing and storing all the information of assignment. So let's say that from step ID 1111, we want to know which permit this person has, then simply we can search this step ID inside assignment table here. So we find the two match, right? Step ID here and here. And this person has a permit 101 and permit 103. So for each of this information, we can search inside permit table. So we search this here, 101, search this here, 103. So that's how we are able to know the information. So if we want to know this person's permit, then we can search this number here. And for the matching information, we can search it here to know more detailed information like this. So same from the permit perspective. So if we want to know who shares permit 101, so we can search this information here. Then we have here match and here another match. So we can find these two persons information inside professor table. So basically that's how main-to-many relationship is modeled in a relational model, in the relational diagram. Okay, so any questions here? So if you have any question, you may ask. If you don't have any question, I'll show you. I'll go to the next one. So the key thing is this. So one thing noticeable is that when you have a main-to-many relationship, basically main-to-many relationship becomes an assignment table. That's why when you have a main-to-many relationship, you are able to store additional attributes inside the main-to-many relationship because it becomes a table. You can add more column to store information. So for example, something like this. So when permit can be shared by multiple professor, we may want to store time, right? So when this professor is able to use this permit. So when permit is shared by two professors, one professor may use this permit during the daytime, another professor may use this permit during the nighttime. So we can specify, we want to specify that time information, then we can put it inside the apply main-to-many relationship. Then when you transform this ER diagram into relational model, then basically, this one is just straightforward and applies becomes assignment table with the primary key of step ID and permit number. And this additional attribute will be simply added here as an attribute of assignment table like this. And then when you implement it, this is straightforward. It becomes a table, and assignment table will become a table with two primary key and additional attribute like this. So that's why many-to-many relationship is able to have additional attributes. Because in terms of implementation, it becomes a table. So that's basically the many-to-many relationship example, how you translate into a relational model. To translate ternary relationship into relational model. So rules are this. Entity with cardinality many becomes primary key of assignment table. So when you have a TC relationship here, entity with cardinality many is semester and course. So their primary key, semester ID and course ID becomes a primary key here, like this, because they are connected by many. And entity with cardinality 1 becomes a foreign key. So here, professor, right? So step ID here becomes a foreign key of this assignment table. And it's quite common. So if you just think from the one entity perspective of the other relationship, then it's always like this when you have a ternary many-to-many relationship. So all relationship between entity and assignment table always becomes one-to-many relationship, which means one-to-many here, one-to-many here, one-to-many here, like this. So that's it. So basically that's the basic rule you can simply follow if you are going to translate ternary many-to-many relationship in the ER diagram into the relational model.